Let's learn the table lookup principle next. Relatively speaking, there are many basic concepts of routing. So we must first lay a good foundation. I've drawn a reference picture for you now. I now make a connection to the line. Certainly. I drew this picture for the convenience of the lecture. If you are planning a project in the future, such planning is a failure. But the lecture, this is a very typical case. For example, it is 192.168.1.0, 24-bit mask. This is a network segment behind this device. This is a 25-bit mask. This is a 30-bit mask. I teach you how to draw. Draw a line here. Add an arrow here. This means that there is a network segment behind the device. Okay. This is 3 network segments. You will find their 192.168.1.0 place is coincident. Let's say this is device 1. This is device 2. Device 3. And device 4 below. We plan the next hop for them. Suppose here is 1.1.1.1. 30-bit mask. Its peer is 1.1.1.2. Suppose here is 2.1.1.1. Its peer is 2.1.1.2. Further down this is 3. 1.1.1. Its peer is 3.1.1.2. They are all interconnected. This is the interconnection address between them. Now no matter how. In short, now I have learned the following routes. Whether static or dynamic. Now this one by one route. Learned all the equipment. Then these 3 routes will be added to the table. There is a routing table on the device. 192.168.1.0. 24-bit mask. Add all 3. Because the identification must be a different destination network segment. So it must be added, regardless of how the rear equipment is connected. But what is happening now is that all tables are added. So now comes a data. This data will go to 192.168.1.2 in the future. So where is the next jump? Think about it. Now comes a data. The destination address of device 1 has been reached. 192.168.1.2. There are now 3 options for the device. Here, here, and here. So where will it be sent from? When the device receives such a route, how to judge which line it should go to? Now there are so many. Which one should be matched? First the local will calculate. When we talked about ARP before, we said that take your own mask and add the IP of the peer. Match with yourself. Router 2. Now the data is going to 192.168.1.2. It will take out all the local matches and calculate them. Look. 24 can match it. The calculation is the 1.0 network segment. Both 25 and 30 are calculated with it. Whoever counts. Calculated and found that this network segment. It means that the data is now going to this destination. All can match. Then the longest mask will now be chosen. That is, we'll select a mask of 30 bits. Since the mask is the longest, represents a longer network bit. Host less. Then the purpose of visiting in the future. Although it is a destination network segment, but in the end it is still a precise destination IP address. The fewer IP addresses covered in a network segment, it means that the network segment is more accurate. For a 24-bit mask, there are 254 usable addresses inside. That is, if it matches the network segment behind the device, it has 254 addresses to match it. But if now go to this 30-bit mask, it only has 2 precise addresses in it. So, If all three can match now, we will choose the one that believes the mask is the longest, because it will be more precise. If this 24-bit mask is matched, it may end up going through a few more routers to arrive. So the path we choose is one step. Choose the most accurate. This is a lookup principle. Then there is a difference between the table lookup principle and the table addition principle. The lookup table principle is called the longest mask match. That is, if there are multiple matching routes locally, it will be forwarded according to the longest mask. Suppose. Now comes a new data. Go to 192.168.1.4. Then it should go to device 3. That is, go to the 25-bit mask here. Then if 1 comes now, 192.168.1.130. The next hop should go to device 2. Because now the maximum of 25 bits can only reach 127. Here are some differences between them. So for now in the routing table, there is a more magical route, called 0.0.0.0. The mask is also 0.0.0.0. Route like this. Let's call it the default route, also known as default route. Let me explain the default route. Draw a simple picture. This is an export router of your company. This is the operator. I won't draw the switch. This is a PC from your company. The router will then access any internet data. Find its gateway, because it must cross the network segment. Find gateways across network segments. The data arrives at the gateway here. Its destination IP now relies on a DNS. The destination IP must be resolved locally. Then it will be sent to the router. For example, data is now going to 2.3.4.5. Such an address. Let's say this is Google's address. Now this device. If you want to help forward, this device must have an address to 2.3.4.5. Assume that a large amount of data will be accessed every day in the future. All such addresses. This terminal has to send data to the public network every day to access services that vary from company to company. Then please, is it necessary for every route of this export device? There are about 800,000 routes on the entire public network. Do you want to go to every address on the public network? Do we need more than 800,000 routes? This device cannot bear such a large routing appearance. If the future comes a data, look up data from the routing table. Match the previous route. Then forward it. That theoretically, I go to the public network. As long as I do the business of the operator, we all take the carrier's equipment. Can go anywhere. Export this device. If there are more than 800,000 routes now, send a piece of data. When searching the routing table internally, more than 800,000 routes retrieved one corresponding forwarded out. From sending data to Google to receiving its reply, maybe 7 or 8 hours have passed. The data has not been sent yet. Secondly, the routing table itself cannot bear such a large appearance. Who will configure it including this appearance? Does the engineer need to manually enter one by one? It's out of the question. If you want to run a dynamic routing protocol with the operator's equipment, first